Hey everyone, here is the warm-up for Tuesday, and what we're doing is simplifying this expression with exponents here. And I'm asking you to do it in regards to a list that I put because I'm finding that some students don't know when they're done. So when you hear me refer to numbers, I'm referring to the numbers of the steps on Google Slides. Okay? So the first thing it says to do is to take care of any exponents that are outside of parentheses. So if you notice, we have this whole numerator in parentheses with this 2 on the outside. Okay, so what we want to do is already start dividing right away and go, oh, I can do these. But in reality, I see a 3 here, but I don't want to do 3 divided by 21. Because this is all in parentheses with something on the outside, it means even though I see a 3, it's not really a 3. I need to apply the operation before I do anything else so I know what these numbers should actually be. Okay, so what I need to do first is take all of these and put them in, and raise them to this actual power here. So that means I'm going to get 3 squared r squared s squared squared, whew, okay, and t to the 4th squared. Okay, so notice I just took every single thing and I raised it to the power. And then all over, and then don't change the denominator, okay? The denominator is not in parentheses. If the whole thing was, then yes, you would, but it's not. So 21 r squared s cubed to the 11th power. All right, so that was step 1. Do the stuff outside the parentheses. Now it says to do all rules so that we can get the expression so that each base only occurs once. So when you're in a monomial like this, you want each base to only occur once. If it's added or subtracted to something, remember you can only add or subtract if they're like terms. So here, I only want the r's to occur once, the s's to occur once, the t's to occur once. So I just need to apply exponent rules to do that. So again, firstly, here, you can follow PEMDAS for this, right? So you would take care of parentheses and exponents before you would do multiplication or division. So what I'm going to do is raise these to their powers. So the rule here is that if you have a power to a power, you multiply. So we have 3 squared, r squared, and then 2 times 2 is 4. So s to the 4th. And then 4 times 2 is 8. So t to the 8th. All over 21 r squared s cubed t to the 11th. Okay, now it says, again, I'm still in step 2. Do all rules to get one base, but I still have 2 r's, 2 s's, 2 t's. So the rule here for division is to subtract. So I want to take the numerator exponent minus the denominator exponent. And I'm actually just not even going to touch the numbers yet. Again, there is some flexibility in this, but since I made it the last step, I'm not going to deal with it until the end. So I'm just going to leave 3 squared over 21 here. And then that kind of maintains my fraction, and I'm just going to put my exponents or my variables next to it. So we have 2 minus 2, that's 0. So r to the 0. 4 minus 3 is 1, so s to the 1st, okay, or to the power of 1. And then 8 minus 11 is negative 3. So we have t to the negative 3 power. Okay. Oof. Okay. There we go. Now, step 3 says to make sure that there's no negative exponents. So when something is fully simplified, we don't actually have negatives in the exponents. So what that means is that every time there's a positive or non-negative, I should say, they go to the numerator. So this r to the 0 and s to the 1st will all go to the numerator with my 3 squared. And my negative will move down to the denominator and become positive. If it doesn't change to a positive, then you know you've done something wrong because it should make it simpler. And if you move it and it's still negative, then you haven't made it simpler. So the numerator is 3 squared because it's the numerator. And then again, all non-negatives go up there. So 0 is not negative. So we have r to the 0, s to the 1st. And then 21 is in the denominator, and then t to the negative 3 becomes t to the positive 3. Okay, made my vinculum a little too long. Yeah, that's the name of the line in the fraction. You're welcome. All right, now Step 4 says to take care of all 0 and 1 exponents. And I have both of those. So the thing is, it's not considered fully simplified because I can actually make these be even more simple. So anything to the 0 power, besides 0, remember that's a weird one, is just 1. So that's 1. And I don't have to write the 1 because 3 squared times 1 is just going to be 1. There's nothing to do there. So I'm going to have 3 squared. You can write parentheses 1 if you feel like it. It's not necessary. And then s to the first power, remember anything to the first power is itself. So this is just equal to s. You don't have to write to the first power. So there you go. There's that. And then 21t cubed. Okay. Last step. Then it says to actually go through and raise all your powers that are numbers to a power and reduce any fractions. So it's dealing with those numbers. So if you have a number to a power, you can actually calculate that with a calculator if need be. But if I have a variable to an exponent like t cubed, I can't do that. I don't know what that is. So I am going to do 3 squared, which is 9. So 9s over 21t cubed, and then I'm going to reduce my fraction. Make sure to wait to reduce your fraction until you've raised your powers, because again, not a 3, it's actually a 9. So if you need to go use the Agile Mind calculator, go for it. Remember, type in 9 divided by 21, and then there's like a little fraction button. Go ahead and watch my video again if you need to on that one, and it will convert the answer into the most simplified fraction, which in this case, they're both divisible by 3. 9 divided by 3 is 3, and then the s. 21 divided by 3 is 7, and then the t cubed. Okay. And then if you want to, you can go back through and make sure that you did, but that would be the simplest form. There's no negative exponents. Each base only occurs once. There's no 0 or 1 exponents, and all numbers have been raised to the power or reduced as fractions. All right, so hopefully that helps. Go ahead and use that those steps if you want to on your practice review today. And of course, email if you have any questions. Good luck.